Hello everybody, today I'm going to explain what are audio filters. A filter is a circuit capable of passing or amplifying certain frequencies while attenuating other frequencies. An audio filter especially is a filter that performs the same activities but within the audio frequency range, which is the human hearing range of 20 Hz to 20 kHz. Well, audio filters form a basic building block of an audio system, in addition to microphones and analog to digital converters. So let's learn more about audio filters, what are their types and what are their applications. Audio filters are referred to as audio amplifiers having distinct frequency responses. So what is an audio amplifier? An audio amplifier only amplifies the input signal without altering the frequency content. Best example is when you increase the volume of your television or speaker systems, you're only increasing the amplitude of sound. You're not messing around with the frequency content of sound. So audio filters are an extended version of audio amplifiers, meaning in addition to amplification and attenuation, they also change the frequency content of the sound. An audio filter can thus extract important frequencies from signals and read out the unwanted or irrelevant frequencies. Alright, let's look at types of audio filters. Well, they're categorized based on construction and based on frequency response. Based on construction, there are two types, just passive and active filters. Well, that is based on the components used, and based on frequency responses, they are classified into different types. In today's video, we'll discuss in detail about passive and active filters, but in the future, I'll make different videos on each of these filters as there are lots of details associated with these filters. Alright, what is a passive filter? A passive filter is designed using passive components like resistors, capacitors, and inductors. And why is it named passive? Is because they don't need an external power source for their operation. Alright, now why are resistors, capacitors, and inductors used? That is because the impedance of capacitors and inductors are frequency dependent. When it is frequency dependent, that's what helps us to do all the frequency related operations like cutting off certain frequencies or letting some frequencies pass through. So there are different types like resistor capacitor, resistor inductor, or all three resistor capacitor inductor combinations. Alright, turns out that passive filters are most responsive to a frequency range of 100 Hz to 300 MHz. So the limitation on the lower end is because of the result that as you go lower and lower, the values of inductance and capacitance required are large, and you need and apparently the sizes of inductors and capacitors also are quite large. So, but that's where active filter steps in and helps us out in the low frequency range. Alright, but as far as audio is concerned, there's not a lot of worries for the high frequency, and because the upper limit of audio is 20 kilohertz, and that's well within the way below 300 megahertz. Alright, these are the passive filter components. The first one is a resistor measured in ohm. The second is a capacitor measured in farad, and the third is an inductor measured in Henry. So these are the components that form part of the passive filter circuit that helps us out with accepting or rejecting frequencies based on the requirement. Alright, let's talk about active filters. So an active filter is designed using active components like transistors, operational amplifiers, in addition to passive components like resistors and capacitors, but not inductors. Alright, the name active is because they do need an external power source for their biasing. And active filters are very responsive to very low frequencies, typically close to 0 Hz, but not suitable for very high frequencies due to amplifier bandwidth limitations. Now we know that active filters only uses active components and does not use an inductor. So this reduces the size and cost of the circuit and also improves the efficiency. Why is it like that? Because we saw in the passive filter case that if you want to go to lower and lower frequencies, you need really large sizes of inductors. In this case, we're not even using an inductor at all. So, there is no need to depend on large sizes of inductors and still achieve the lower cutoff frequencies. Here is an active filter component. It's a transistor and it's measured in volts. Alright, let's look at some application of filters. So the first one is audio crossover. What is an audio crossover? It is an electronic filter used inside speakers to split the input audio signal into different frequency ranges. So it's like you're taking the input signal and you're splitting them into, certain categories like low frequencies, mids, and highs. And you're directing them to the respective drivers. For example, lows are directed to woofers, mids to the mid drivers, and high frequencies to the tweeters. Let's look at a diagram. Alright, this is the audio crossover circuit. So as you can observe here, you have an input signal and that is split into three parts in this case. So one goes to the low pass filter, one to the band pass, and one to the high pass. So the one that is going to the low pass filter, that low pass filter is only going to allow the low frequency to pass through. And it is directed to the woofer, which is like a low frequency driver, and then that spits out the low frequency waves. The same phenomena happens here, in the band pass filter. It allows a certain band of frequency. So that's like, the ones that are not bass and not treble, so the mids. And the mids are directed to the mid-range drivers, and they spit out the mid-range sound waves. And the same happens with highs. So this is a simple example, but there are more complicated speakers, subwoofers or high tweeters, but the principle is the same. Alright, another application of filter is an audio equalizer. So what is an audio equalizer? It is an electronic filter used to amplify or attenuate the audio signal based on the frequency dependent function. So certain frequencies are boosted, certain frequencies are cut, and there is, immense flexibility to do so. A user can, boost or cut frequencies as per the requirement. And as a result, the output has different amplified levels or attenuated levels for different frequencies. Now this is a whole nother topic called equalization filters, which we will discuss in a separate video, where I'll also be demonstrating using some software so that it's easier to understand and grasp. Alright, thank you for watching this video. I hope you enjoyed it. If you have any questions, hit the comments and I'll be sure to respond. Alright, thanks a lot. Have a great day.